Hello and welcome to Automating Tasks with the Bash Shell, which continues the Computational Research Skills series. My name is Steve Crouch and I'll be introducing the Bash Shell, what it is, how it can help you in your work, and I'll also give you an outline of what you'll be learning about in this lesson. So, to give you a taster of why it's useful, one of the great things about the Bash Shell, and the feature I use all the time, is that it's really good at doing the same tasks over and over again. For example, if you had 100 data files and you needed to rename them all in a certain way, perhaps adding the dates they were created to the file name, you wouldn't want to do this manually for every single file. It would take a very long time. But by learning a few things in Bash, you'll be able to do this in a fraction of the time by automating the process. And this is among the things you'll be learning in this part of the course. And I hope you'll find Bash as useful as I have over the years. First, I'll cover some acknowledgements and links to some related resources. The first link is to the training material for today. It's based on the Unix shell lesson materials developed for the software carpentry curriculum. Now, software carpentry itself is part of a wider initiative and community called the Carpentries, which, along with other types of carpentry such as data and library carpentries, aims to teach foundational computational and data analysis skills to researchers. And these courses are delivered as two-day hands-on workshops. The focus of data carpentry is on teaching introductory computational skills needed for data management and analysis, and it's based around the programming languages of R or Python. Whilst library carpentry aims to build software and data skills within library and information-related communities. Another type of carpentry exists called high-performance computing carpentry, or HPC carpentry, which, whilst not an official carpentry lesson, takes a similar format and ethos. Finally, you have the one that started it all, software carpentry, from where this Bash lesson originates. It has a more computational focus and aims to teach skills for programming in Python or R, version control, and also the automation of repetitive tasks using the Bash shell, which is what you'll be learning about today. Now, you may recognize this typical data journey diagram from Alex's introductory presentations on data organization and management and OpenRefine. So within those presentations, Alex covered tools and techniques to help with specific parts of this pipeline at the data acquisition and data cleaning stages, which help you to arrive at an informed decision about a research question that you have. But for this lesson, we'll be looking at a tool that is often used anywhere within this pipeline, and especially for overcoming challenges that are typically faced within pipelines such as this. One situation you'll likely come across is the need to run the same program many times over a lot of data. This may be tens, hundreds, or thousands of input data files, for example. And as we've said, this is one thing the Bash shell is really good at, iteratively running programs over a lot of data to generate results. Another of these challenges is the number of tools and software you can end up using throughout such a pipeline, and the process you need to use to execute each tool at the right stage at the right time. So in the OpenRefine lesson, for example, you've looked at using OpenRefine as part of data cleaning to get your data into a better state for data analysis, and how to export the cleaning process you create in a format known as JSON. During data analysis, you may have analytical or simulation programs that generate output based on this data. And following this logically, you could also have other programs that generate data visualizations, perhaps charts and graphs, based on the output from the data analysis stage. Each of these ideally becomes an automated step in this pipeline. And the great thing with the Bash shell is that it acts as a kind of glue to help you tie these pieces together. So either part, or ideally the whole of the pipeline, becomes automated. And just by running a script or two, you can then regenerate your end results or graphs from the input data. So what is the Bash shell? Well, essentially it's a text-based program that interactively allows you to run other programs. You'll be familiar with the graphical way of dealing with computers, like the interfaces that Windows and Macs give you. You run an application, it gives you windows and buttons and menus to interact with, to access its functions and achieve a result. The Bash shell also gives you a means to access the functionality provided by your computer and other programs, but it does so in a different way. It allows you to type commands into your computer to get results instead. So when the command is finished running, it prints out the results to you. And then the shell allows you to type in another command, which then gives you results from running that command, and so on. Now, as well as giving commands to the shell interactively, we can also capture sequences of commands in files, which are called scripts. and then we can run these scripts whenever we need to run those sequences of commands again. So why use the bash shell? In general, being able to capture how programs are run and in what order in something like a bash script and essentially automating how we run that process is invaluable. It's really helpful when making your pipelines reproducible. Once you've defined this process, you can rerun it whenever you want. And this is both helpful for others to achieve the same results that you have, but also for yourself. Perhaps this could be used 6 months from now when it would be otherwise difficult to remember what it was exactly that you did. And so what you're effectively doing is building a narrative. You're telling a story in recorded programmatic form of how you generated your research results. And building on that is repetition. We've mentioned already that bash is great at repeating the same commands many times. This could be renaming 100 files, or it could be something more complex, such as running a data analysis program over many input data files, or running a program to generate a chart for every one of those output data files produced by that program. Another benefit is that bash is available on different types of machines. You can already use the bash shell on computers like Macs and those that run Linux, where it's already installed, but you can also install and use it on Windows. Another reason is that you can use it to run other machine resources, such as a supercomputer, to run your programs even faster. And these kinds of resources almost exclusively use the shell. Now, on the flip side, it does have a steeper learning curve, generally, than using graphical programs, but knowing just a little can still be very useful. And in your careers, you will likely come across quite a few programs that have command line interfaces, so it's helpful to know a bit about it. So here's an outline of the topics we'll be covering with the bash shell. You'll first be looking at running the shell and how to access your files using it, as well as how to run programs using it too. The second topic will be things you can do with files, such as creating them, copying, moving, and renaming them. In the third topic, you'll be learning about how to combine commands together, a key feature of the shell, as well as how to capture and reuse results you receive from programs. The next topic is going to be about writing programs in bash, which are known as scripts, to run a number of commands in sequence, allowing us to reuse them later. And in the fifth topic, we'll be learning about how to use bash loops, a very useful feature that allows us to run commands many times over different inputs. And finally, you'll be looking at two very useful commands for finding things using the shell, either searching for particular text within files or searching for files themselves. So instead of being conducted over the course of just one session, this session is going to be done over 2 sessions. There will be another session for bash shell the following week where you can continue the lesson materials. To start with, we'd like you to focus on just the first 3 topics. So see if you can get to pipes and filters in the first session, and if you can't, don't worry, you can either finish them in your own time or come back to them the following week. Then, in the second session the week after, you can focus on the last 3 topics. So bash has been around for a long time, since about the 60s. And there is always more you can learn beyond this lesson. So here are a few of the many resources out there that you may find useful. The first is a guide produced by the Software Sustainability Institute about how to write readable code, a helpful resource for novices that will help others, as well as yourself at a later date, understand the code and the bash scripts you've written. The second is a couple of comprehensive tutorials on more advanced shell topics. And lastly, there is a bash cheat sheet, a quick reference you can use to look up widely used bash commands, what they do, and how to use them. The last thing I wanted to say is good luck to everyone with the material, and I hope you find the bash shell to be as useful as I have over the years. And we'll see you later for the question and answer session.